In this video, we're going to factor quadratic equations. We're just going to do some basic factoring. To start out, let's talk about what factoring a quadratic is. It's the opposite of multiplication, which we usually use the FOIL method. For example, a lot of times use the FOIL method. For example, if I was multiplying these two binomials together, x plus 3, x minus 5, if I would FOIL them or use the distributive property, which is the same, we would get this quadratic in standard form. So that would be when we're multiplying. Now factoring is when we take this standard form or some quadratic and we take it back to all its factors like this. So we're going to go the opposite direction. When we do the factors, we want to have them in simplest form. We want to have all factors listed out. So what we're going to do is one of the techniques we'll use is we're always going to remove any common factors first. And so if I look at what I have listed here, we're going to see if we have any common factors in there, and what we see is that we could pull out a 4 out of this, and probably we want to pull out a negative 4. So if I pull a negative 4 out as a factor like this, then what that's going to leave is, you could think of taking a negative 6x and dividing by a negative 4, because I'm going to pull the negative 4 out of that term. That would give us 4x. And if I would take 56 and pull a 4 out, you would get 14. And now looking at this, you could see that we could actually pull another term out. So what I could have pulled out originally, instead of pulling out a negative 4, I could have pulled out a negative 8. But after I pulled out the negative 4, I can see that I still have some work left to do. So what I'm going to do now is I'm going to pull a 2 out of each of these terms. So if I pull a 2 out of both terms, that 2 would go to the outside and give me a negative 8 now. And what I would have left is 2x plus 7. Okay, looking at the next one, we can see that we have an x squared in both terms, so I definitely am going to factor an x squared out. And then I have a 20 and a 16, so a common factor there would be 4. So if I pull a 4x squared out, what I would have left, you could think of it this way, taking a 4x squared out of that term, I would have 5x. And if I took a 4x squared out of this term, I would be left with plus 4. So that would be my answer. Okay, looking at the next term, let's see what we can pull out of here. 48, and I have a 12. And 12 will not divide into 42, so it looks like maybe a 6. So if I pull a 6 out, that would give me 8r squared. If I pull a 6 out of this term, I would get plus 7r, and 6 out of here, it would be plus 2. The next one, you can see that I have an n cubed and an n, but there's no n in the last term, so I can't pull an n out, but I can pull a 2 out. So 2, and that would give me 10n cubed plus n plus 7. That's pulling out a common factor or a monomial. Another factoring technique that we have is a difference of squares. And that's going to be a unique kind of factoring in that I don't have an x term in the quadratic. Or the middle term in this case, it would be that I wouldn't have an m term. So the term like x, or where there's no square on it, isn't there. And this is how a difference of squares is formed. Let me just give you an example. Is if I would have, let's say I would have something like x minus 2 times x plus 2. When I multiply this out by FOIL, I'm going to get x squared, then I'm going to get plus 2x, then I'm going to get the negative 2 times this x, I would get minus 2x, and then finally a minus 4. So x squared minus 4. So what's happening is notice that I have an x and a 2 and an x and a 2, but one has a minus and one has a plus, but everything else is the same. Well, what happens is when I multiply them, I'm always going to get like a plus 2x or a minus 2x, and the middle terms are going to drop away. And all that's going to be left is this x times this x, and this negative 2 times this 2. So that's how I get the difference of squares, because the first term would be x squared, and the second term would be 2 squared, and in the middle, because of the subtraction, I would have a subtraction. So this is a difference of squares. And once again, the x term has gone away. So how I factor these is like this. I'm going to take a look at the first term and the last term, and I'm going to see if I can pull any common factors out, just like I always do when I factor. And sure enough, it looks like I can pull a 3 out of this. So I'm going to pull a 3 out, and then I'm going to get 4m squared minus 9. And now look what I have left. There is no m term in the center, so that follows with what I said we need to have. The first term is a perfect square, the last term is a perfect square, and they're subtracted. So this is a difference of squares. So I can't lose my 3, but what I'm going to do is I'm going to say, okay, what's the square root of 4m? Okay, that's 2m. What's the square root of 9? 3, and subtract. So I have 3 times 2m minus 3, and then I have to add 2m plus 3. So I'm always going to add the same numbers, one subtracted, one with a plus. Let's look at the next one. Okay, no x term, perfect square, perfect square. So the square root of 25x squared, well, that's 5x. Now minus the 3, the square root of 9. Okay, then 5x plus 3. The next one. I need to see if I can factor something out of this. If I factor a 5 out, that would give me 16k squared minus 25. Oh, look, I have a difference of squares. It's a perfect square minus a perfect square. So 5, the square root of 16 is 4k minus 5, and then 4k plus 5. Last example for this. Once again, no x term, perfect square, perfect square. So let's take the square root of the first term minus the square root of the second term. Square root of 4 is 2. 4x plus 2. Okay? Let's go on to another factoring technique called basic quadratic factoring. And as what we'll see now is we'll have a trinomial. It will have 3 terms, and it will have an x term in there. And the technique we're going to use is only going to work is if the coefficient in front of the x, that's a, remember in standard form we call that a, if that's 1. So we won't actually show the 1, we just won't see a number in front of x squared. Over here I have a trinomial that has 2x squared plus 2x plus 5. This 2, because it's not a 1, means that I cannot use this method. Remember, you do not use this method if I have anything in front of the x squared other than a 1. And since it's a 1, we're really not going to show it. Now let's look at what happens when we do the FOIL method. So here I have a basic set of factors, and I'm going to FOIL them, or distributive property. And if I do that, I get x squared plus 2x minus 4x minus 8. And then, of course, the 2 and the negative 4 add, I get x squared minus 2x minus 8. And when we look at this, you can see that these numbers, 2 and a negative 4, they actually will add together to give me the middle term. They're going to multiply together to give me this last number term, this minus 8. So when I'm factoring with this basic method, what I'm going to do is I'm going to actually look at the x term, and I'm going to say, okay, what 2 numbers add to give me this number? And they multiply to give me the last number. Because that's what actually happens when I use a distributive property. Okay, so let's take a look at this. Here's a quadratic expression, and it's trinomial. So I'm going to look and I'm going to say, okay, what numbers add to 3 and multiply to a negative 5? Add to 3 and multiply to a negative 10. Okay, that would be the numbers 5 and a negative 2. So I can write my factors, x plus 5, x minus 2. Let's look at another one. I'm looking for two numbers that add together to give me 1 and multiply to negative 2. Okay, how about a negative 2? No, let's change that. 2 and a negative 1. 2 times a negative 1 is a negative 2. 2 plus a negative 1 is 1. So my factors are x plus 2, x minus 1. In this next one, it looks like I could factor a 4 out first. Remember, always look to see if we could factor something out. So that would give me 4. I would have n squared plus 2n, and 4 would divide into 96. 4 would go into 9 twice, and carry 1 would be 24. So now what I'm looking for two numbers that add together to give me 2 and multiply to a negative 24. Well, how about 6 and a negative 4? So I would have, and we can't lose that 4 out there, so it's 4, n plus 6, n minus 4. Okay, let's look at the next one. It looks like I can factor a common factor out, so let's do that first. Because look at this, I wouldn't be able to use this technique with a 6. It has to be a 1, right? So fortunately I can factor a 6 out. And if I factor a 6 out of negative 420, I get a negative 70. So now I'm looking for two numbers that add to 3, multiply to a negative 70. Well, how about 10 and a negative 7? That would multiply to negative 70 and add to 3, so 6 times x plus 10, x minus 7. And the last one, it looks like I can pull an x out of each number and also a 5. That would give me x squared minus x minus 6. Two numbers that add to a negative 1, multiply to a negative 6. How about a negative 3 and 2? So I would have 5x times x minus 3, x plus 2. And let's just check one of these to make sure that what I'm telling you is true. So if I would use the form method on, say, this one, I would get x squared minus x plus 2x minus 2. X squared plus x minus 2. Sure enough, that's what I had at the start. So that's how you do this, the basic factoring.